Hyperconjugation. So hyperconjugation is a general stabilizing interaction. It involves delocalization of sigma electrons of CH bond of an alkyl group directly attached to an atom of unsaturated system or to an atom with an unshared p orbital. The sigma electrons of CH bond of the alkyl group enter into partial conjugation with the attached unsaturated system or with the unshared p orbital. Hyperconjugation is a permanent effect. To understand hyperconjugation effect, let us take the example of CH3CH2 positive ethyl cation, in which the positively charged carbon atom has an empty p orbital. One of the CH bonds of the methyl group can align in the plane of this empty p orbital, and the electron constituting CH bond in plane with this p orbital can be delocalized into the empty p orbital, right, as shown in the figure. So this is the sp3 of the sp3 hybrid of this, and this is the hydrogen 1s. So this interaction with this empty p orbital, so this type of overlap stabilizes the carbocation because the electron density from the adjacent sigma bond helps in dispersing the positive charge. So let it be, this is the positive charge, so let this, so ये CH, सो ये H पॉजिटिव यहाँ से निकला, यहाँ नेगेटिव चार्ज, सो पॉजिटिव और नेगेटिव ने ये बॉन्ड बना लिया. अब अगर ये H पॉजिटिव कर सकता है तो ये H पॉजिटिव भी बना सकता है. इसी तरह इसका भी नेगेटिव चार्ज इधर आया और इसने ये डबल बॉन्ड बना लिया. इसी तरह ये वाला H पॉजिटिव भी H पॉजिटिव बना सकता है और इधर क्या आ गया, इधर नेगेटिव चार्ज और इस नेगेटिव और पॉजिटिव ने ये वाला बॉन्ड बना लिया, राइट. So in general, greater the number of alkyl groups attached to a positively charged carbon atom, the greater is the hyperconjugation interaction and stabilization of the cation. Thus we have the following relative stability of carbocations. So tertiary carbocation, because it has the 9 hydrogen taking part in hyperconjugation, then this has the 6. This is the secondary cation, this is the primary carbocation, and this is the methyl carbocation. So hyperconjugation is also possible in alkenes and alkyl arenes. So delocalization of electrons by hyperconjugation in the case of alkene can be depicted as, so this is the double bond and this is the interaction with this pi bond electrons. So there are various ways of looking at the hyperconjugative effect. One of the ways to regard CH bond as possessing partial ionic character due to resonance. So let this be alkene. So now this electron comes to this carbon, so 8 positive charge is created. Now this H positive leaves the electron here and negative charge, so this positive and negative makes this bond. So this is due to this hydrogen. No, next time it is due to this hydrogen, and next time it is due to this hydrogen. So 3 hyperconjugative structure, resonating structure due to is possible. So hyperconjugation may also be regarded as no bond resonance. No bond resonance. There is no bond, but there is a resonating structures. So one question we have explained why this is more stable than this and this is the least stable cation. Hyperconjugation interaction of this is greater than this, as this has the 9 CH bond and in CH3 vacant p orbital is perpendicular to the plane in which CH bond lies, hence cannot overlap with it. The CH3 lacks hyperconjugative stability.